This is lesson 6.39, Ratios in Similar Solids. The objectives are to solve problems with similar solids or shapes and work with their ratios, whether you're working with 1 dimension, 2 dimensions, or 3 dimensions. First, let's talk about items that are only 1 dimension. Length, width, height, the radius, the perimeter, even the scale factor. Those are examples of 1-dimensional measures. 2-dimensional measures are area, surface area, lateral area. Anything with the word area is 2 dimensions. Volume is 3 dimensions. There are others that would be examples of 1 dimension, 2 dimension, or 3 dimension. But just remember, as long as it says area, it's 2. As long as it says volume, it's 3. If it doesn't have those words, it's 1. So, if you have 2 similar objects, and you're converting from 1-dimension ratio to a 2-dimension ratio, then A to B will become A squared to B squared, which means if 2 similar objects have a 1-dimensional ratio of 2 to 7, then the ratio of, say, their areas would be 2 squared to 7 squared, which is 4 to 49. If 2 similar objects have a 1-dimensional ratio of A to B, and then you want to know the 3-dimensional ratio, you would cube the dimensions. So a 1-dimensional ratio of 3 to 5, what would be the 3rd dimension ratio? Well, cube each one. 3 cubed to 5 cubed will become 27 to 125. If you have a 2-dimensional ratio and you want to know what the 1-dimensional ratio is, from 2 to 1, you will square root the ratio values. A to B becomes the square root of A to the square root of B. So a 2-dimensional ratio of 36 to 25, its 1-dimensional ratio will be the square root of 36 to the square root of 25, which is 6 to 5. If you start with 3 dimensions and want to know the 1-dimensional ratio, from 3 to 1, you cube root the ratio. So A to B will become the cubed root of A to B. So a 3-dimensional ratio of 343 to 729, the 1-dimensional ratio would be the cubed root of 343 to the cubed root of 729. The cubed root of 343 is 7, the cubed root of 729 is 9. So the 1-dimensional ratio will be 7 to 9. If you start with 2 dimensions and want to make it 3 dimensions, you have to go through one dimension first. So we're really going from 2 dimensions to 1 dimension, then to 3 dimensions. From 2 to 1, we square root. And then from 1 to 3, we cube it. So square root first, then cube it. A 2-dimensional ratio of 4 to 9, to become 3 dimensions, we square root to get 1 dimension, and then we cube it to get 3 dimensions. The square root of 4 is 2. The square root of 9 is 3, giving us 2 cubed to 3 cubed, which becomes 8 to 27. From 3 dimensions to 2 dimensions, you also have to go through 1 dimension first. So from 3 to 1, we cube root to value. Then from 1 to 2, we square it. Cube root first, then square it. A 3-dimensional ratio of 1,000 to 343. To make it 2 dimensions, first we cube root it, then we square it. Cube root it, then square it. Cube rooting 1,000 is 10. Cube root 343, it's 7. So we have 10 squared to 7 squared, which is 100 to 49.